Another aspect of doing algebra is being able to factor expressions, make them simplified, make them in a form that you can deal with, and that's what this video is going to be about. I'm going to go through some common ways to factor different expressions and equations you'll see on the SAT. So the first and really important one, because it's a great shortcut, is remembering how to factor two perfect squares, the difference of two perfect squares. So if I'm given something like x squared minus 16, this is just x plus 4, x minus 4. The general form of this is if I have some x squared minus y squared, it's just the same thing as x plus y, x minus y. So notice both of these are being square rooted. We're going from x squared to x and 16 to 4, and then it's just plus and minus. This is a very important form to remember and be able to work with, because on certain questions, if you remember this, it just makes them go much more quickly. You don't have to worry about trying to factor it. It's a whole big thing. How about the next, finding common factors? This is something we referred to a bit in the factors video when we talked about finding the greatest common factor, the GCF. And this is something where you're going to use, for instance, in undistributing, in pulling things out based on the distributive property. So imagine I'm given 10x squared plus 4xy plus 16xy squared. What is the greatest common factor of all these terms? What is the greatest factors that these guys share? Well, let's look at the numbers first, 10, 4, and 16. Well, they all have a 2. They all don't share a 4. He has a 4 and he has a 4, but 4 doesn't go into 10 equally. So let's just go ahead and pull out a 2 out of all of them. How about the letters? Well, this one has 2 x's. He has 1x and he has 1x, so we can pull an x out of all of them. These guys have at least 1y, but he has no 1y, so we can't pull a y out of him. So we pull a 2x out of everything. What are we left with? Well, 10x squared, you pull a 2x out of it. It's the same thing as dividing 10x squared by 2x. I'll be left with 5x when I do that. And notice 2x times 5x will multiply back out to 10x squared. Here, my 2 goes into my 4. I leave 2 behind. The x disappears, but I still have the y. The 2 goes into the 16, leaves us an 8. And the x disappears, but we still have the y squared. So this would be the factored version of this particular expression, using the distributive property and using the greatest common factor. How about foiling? So foiling is just a way of multiplying these two binomials together. So for instance, if I have something like x plus 3 times x minus 3, I'm going to multiply the first, and then the outside, and the inside, and then last. So first is x times x gives me x squared. Then I'm going to multiply the outside, so x times 3 gives me, or negative 3 gives me minus 3x. So let me change that. Okay. Minus, whoa, where'd my pen go? Minus 3x. Now I'll do the inside. So 3 times x is plus 3x. And then the outside, 3 times negative 3 is minus 9. So notice here, negative 3x plus 3x will cancel, and I'm just left with x squared minus 9, which makes sense because this is the difference of two perfect squares, right? But that's foiling. It's the first times, or first, then the inside, then the outside, or whatever you want to do it in. The first, outside, inside, last. Let's look at some examples of some other ways of foiling. How about x plus y squared? Is another one that's useful to remember. Let me go ahead and just factor this for you, or foil it. So x times x gives us x squared. X times y gives us xy. Y times x gives us another xy. And then y times y gives us y squared. And if I combine this together, I'll get x squared plus 2xy plus y squared. Yet another useful thing to remember. When you have x plus y squared, it's the same thing as this. Again, you can always come up with it by doing the foiling, but if you at least have it memorized, it just moves things a bit quicker. How about this one? X minus y squared. X minus y times x minus y. I foil this and I get x squared minus xy plus y squared, which turns into, when you combine the like terms, minus 2xy plus y squared. Sorry for the dog. And that would be the particular expression. So again, memorize that x minus y squared equals this particular term. And that's pretty much it for some of the factoring stuff. Factoring is not huge here. I mean, it's relatively important in Algebra 1 and Algebra 2, but on the SAT, not really. For certain problems, it makes them easier, but that's about it.